Hello everyone, this is Miss Jones. I will be doing your notes tonight on Newton's second law. Now the information we will be going over is information we've already discussed in class, but these notes will hopefully just take things a little more in depth for you and clarify any questions you're having on the material. So, as we talked about in class, the very first thing to know about Newton's second law is how we define a force. So a force is defined as anything that has a push or a pull. And that force is determined by the strength and direction. Now, when talking about forces, it's important to understand which object is applying the force and which object is having the force applied upon it. So if we use an example of a person, which I'll draw my little person here. Sorry about my terrible stick figures. A person is, let's say, pushing a cart. Alright, so the cart is moving this direction due to the force the person is putting on it. So therefore, in this example, you'll see that the person is applying the force and the cart is having the force applied onto it. So the person is giving the push and then the cart is moving. So the person is applying the force, the cart is feeling the force. Now, as we saw in our examples in class, forces can be added or subtracted from one another. If the forces are being put into the same direction, they add together. If the forces are in opposite directions, they subtract from one another. We saw this with the examples of the students pulling the rope, where if two students are pulling in the same direction, their combined forces are added together. And if there's a student pulling in the opposite direction, their force is subtracted from the total. Now, talking about adding and subtracting forces together brings us to something what we call net force. And the net force is the overall force once the forces have been added together or subtracted from each other. Alright, when discussing a net force implies that there's going to be an unbalanced force because there's going to be an object is going to be accelerating. Alright, we saw this when we had two students pulling a third student into one direction. If one person is accelerating, then there was an unbalanced force causing that motion to occur. There can also be something called a balanced force, in which will not change the object's motion. Alright, this was the example where we had one student on either end of the rope, both pulling in opposite directions. When neither student moved, that meant that the forces were in fact balanced and there was no acceleration, there was no change in motion. Acceleration can be very easily calculated if you know both the mass and the force exerted on the object. And this brings us to Newton's second law, which allows us to do just that. Newton's second law states that the acceleration of an object is equal to the net force put on it divided by its mass. That is restated below in an equation form, stating where acceleration equals net force divided by mass. This is abbreviated to be A equals F divided by M. Now, this is an equation we can very easily manipulate algebraically to be written in two different ways. The most common being F equals MA. This is the most common way you generally see this Newton's second law written, but it can also be rewritten to be M equals F divided by A. All three of these are equal, it just depends on which of the three you need to be solving for, so that's how you need to rearrange them algebraically if necessary. Now, before we can jump into an example problem, we need to know the units, because as we know, units are very important in science. So, a Newton is what the SI unit is for force, and that's written just with a capital N. Now, a Newton, all that really stands for is it stands for kilograms meters per second squared. It's just a simpler, more efficient way of writing that. Kilogram, as we know, is the SI unit for mass. And then meters per second squared is the SI unit for acceleration. It's important to notice and to note that this is really what a Newton is equal to, because as you will see in the next slide when we do an example, when you have something where it's F equals MA, our force is going to have a Newton as its unit, our mass is going to be kilograms, and our acceleration is going to be meters per second squared. And the reason all of these work is because a newton really equals a kilogram meters per second squared. And so that's how they all fit together. So it's important to note that for when we go on to our next slide with the example. Alright, here we have that example where we have a 52 kilogram water skier is being pulled by a speedboat. The net force on her is 104 newtons. Calculate the acceleration that causes this force causes. So the first thing we need is we need our equation, which we have is acceleration equals force divided by mass. Alright, so looking at our problem, we can find those different parts in the problem. So we're solving for acceleration. We see that here. And we're given the mass of the water skier being 52 kilograms. And her net force is 104 newtons. So plugging that all in, we have acceleration equals 104 newtons divided by 52 kilograms. And here is where it's important to understand what really goes into a newton, so when we go to look at our units, we understand why acceleration is going to be in meters per second squared. So doing this division problem is pretty simple. So we're going to get that acceleration equals 2 meters per second squared. Again, understanding what a newton is equal to allows us to get to that unit. Alright, I hope this cleared up any questions you were having during class, and if you still are having any problems, feel free to ask questions on Edmodo. Myself or other students will be more than happy to answer you. If there's still things you don't understand, we'll be going over this and doing some more example problems in class tomorrow. I'll see you then.